Hello class, today we study the chapter 2 about input-output. That means you study input-output devices and the mechanism. That means the way how input-output devices or our computer work with input-output devices or how it connects to the outside world. For example, when we study, we can ask the question, where does data in memory come from? How does the data get out of the system so that humans can use it? Over here, we study volume model with the computer and with input-output devices such as monitor, keyboard, mouse, printer, scanner, etc. So there are two important factors when we study input-output devices. The first, behavior for input-output storage devices such as keyboard, monitor, disk. The second, data rate. That means we can answer the question, how fast can data be transferred? And when we program for data fetching between our computer and the outside world, that means the way to interface between our computer and input-output devices, we have some problem. The first, instructions. The second, timing. The last one, control. For instruction, we study memory map as special instruction. For timing, there are two small mechanisms, asynchronous and synchronous. And the last one, we have two small mechanisms or two ways. The first, polling, and the second, interrupts. For the first, memory map I/O, at that time, we must represent device register as memory addresses. That means we use some location in our memory for representing our input-output device register. And if you want to work with our input devices, we use load and store, you study. And the second, we can work with input-output devices, we use a special input-output instruction. With the LC3, we don't use this. For transport timing, we have two mechanisms. The first is synchronous, the second synchronous. For asynchronous, the data rate is like predictable, like keyboard. We have small problem. Maybe we miss the data and we can solve them with hand setting. At that time, we use a ready bit from our input-output devices. And when we say our input-output device is ready, that means it's ready for each function. For synchronous, we have data supply at a fixed or predictable rate. And at that time, the CPU can read and write every extra cycle. The last one who controls the interaction. We have two ways. The first, polling, the second, interrupt-driven. For the polling, the processor can control the interaction, and we always ask if the I/O data is ready. At that time, we can ask many times, are you ready, are you ready, are you ready? But when we use the interrupt-driven, the I/O can control the interaction, and processor is interrupted by the announcement from I/O. At that time, you can answer, or we can say, now, wake me up when you are ready. Generally, we have 6 mechanisms, but in fact, with the LC3, we don't have all, so we have only 4: memory map, I/O, asynchronous, polling, and interrupt-driven for programming. So over here, for memory map I/O, we use some location at the addresses for KBSR, KBDR, DSR, DDR. OVS, that means status, and D, data. And we have bit 15. Bit 15 is data register for a ready bit. And in data register, we use only 8 bits from bit 0 to bit 7 for the data. Beside them, we have input-output controller. Input-output controller with this. You know, in this controller, we have control data register over here. Because we say control, that means the CPU tells the device what to do. That means CPU can write something or some bit to control register. The CPU want to know at that time. CPU checks where that task is done at that time. The CPU can reach data register to know. And we have data register. So CPU can transfer data to or from input-output devices. Besides, we have device electronics. So over here we have instructions. In fact, with DLC3 we don't study. We don't have any instruction like this. But generally with the real CPU we have some instruction to do with this. So we call them special input-output instruction. But with DLC3 we don't have any memory map I/O. So over here we have some memory location for our input-output device register over here. And we use some load and store instruction to read out or to write the data or to read out and to know the status. These are the memory, their secret memory. You know, over here the address of KBSR, the address of KBDR, DSR, DR. So they are device register. And now we go to the first input from keyboard. When we say we input from keyboard, that means we use the keyboard for inputting the data to our computer, to our AC3 computer. You know, when we want to input the data, so pay attention to the ready bit in KBSR. We have the bit 15. So over here, the bit 15. Over here, we have the bit 15. And pay attention when we say our keyboard is ready. At that time, when a character is timed, that means each ASCII code is placed in bit from 0 to 7 of data register. And pay attention, the bits from bit 8 to bit 15 are always 0. The bit from bit 0 to bit 7 is the ASCII code of the character widget type. Okay? At that time, that the ready bit, that means data register 15 is 1. So it's 1 to say now we have a register in our data register, okay, and we can use them. At that time, the keyboard is disabled. That means we could input any character. And when the data register is read, at that time, the data register 15 is set to 0. And the keyboard is enabled. That means we can enter the other character.